Question number 49, group anagrams. This question is pretty straightforward. It tells us that given an array of strings, we're going to want to group all of the anagrams together and that we can return our answer in any order. Then it sort of tells us what an anagram is, but for the purpose of this video, I'm just going to assume that you already know what an anagram is. So let's start by just talking a little bit about anagrams in general. And so let's take a look at some of the anagrams that they give us. Eat, tea, tan, ate, nat, bat. Let's just start with these first two, eat and tea. And so what you'll notice is that just by virtue of being an anagram, they have the exact same frequency of the exact same letters, right? And so what's interesting is that they are all going to have the exact same string representation if you sort all of the characters. So if we sort each of these letters in ascending order, A comes first, followed by E, followed by T. And if we just create a string out of each of those, or out of that set, that gives us AET. The exact same can be said of T, right? T, E, and A, when sorted, are going to produce A, E, T, which gives us the string AET. And what's really important is that this is unique for each set of anagrams. So for example, if I decided to add bat to the mix, you'll notice that when sorted, these characters are A, B, T, which gives us ABT instead of AET. And so we're going to use this sort of idea in our solution here. And so let's break our solution up into a couple of different parts. In the first part, we're going to want to convert each string to its sorted character representation. The second thing we're going to want to do is group all sets of anagrams. So a set in this case would be eat and tea, but not bat, because eat and tea are anagrams with one another, while bat is not. And once we've grouped all of these sets, we can finally go ahead and return our set of sets, right? If we take a look at the return type here, it's going to be a list of strings, where each of those lists of strings is one set of anagrams. So with that out of the way, let's go ahead and begin coding. The first thing that I'm going to want to do is convert each string to its sorted character representation. And so instantly I know that I'm going to have to iterate through all of these strings. So I'll say for each string S in our set of strings, let's go ahead and first start by finding the character array of a given string. And doing that is super simple. We can just go ahead and define a character array. I'll call it CA for character array. And it's just going to be the string in question, our current string, to char array. It's going to give us that value. And then we're going to want to sort our CA character array. Doing that is also super simple. We'll just use our arrays.sort method, which we know is going to run in n log n time. We'll talk about the time and space complexity after we finish. But now we know that our CA array is fully sorted. And so the last thing that we need to do, we're at this stage right now, the last thing we need to do is convert that back into a string. And so the way we're going to do that is super simple. We'll call this string key equals, not new, it's just going to be string dot value of CA. All right, and so we've finished step one here. Now, the big question is, how are we going to group together all of our sets of anagrams? Well, what you'll notice is, just as before, when we talked about how we can confirm whether two strings are anagrams with one another, they produce the same output in their sorted character representation. And what's really, really important is that if we think about this sorted representation as a sort of key, what you'll notice intuitively is that we can throw a hash map at this problem, and that makes our lives a lot easier. And this may be a little different from most of the hash maps that you've engaged with, because this hash map, let's go ahead and define it as we talk about it. This hash map will have a string for its key, right? This will be our string. and we want to store within that string a list of all of the anagram sets. And so our value here is going to be an array list of strings. Let's just go ahead and call that Anna to represent all of the anagrams. And let's go ahead and instantiate it as well. All right, and so what you'll notice is that now we have a key. All we need to do now is add our current string to the hash map that we've created under this key. And so there are a couple of different scenarios. The first scenario is our hash map, Anna, already has that key. It's already seen another similar type of string, which is an anagram to our current one. And so if Anna contains our key, then what we're going to want to do is simply get the array list that already exists at our key representation and add to it our current string. Now, in the other case, if Anna does not have our key, then first we're going to want to go ahead and add our key. So we'll put our key in, and the value that we'll associate with it is just going to be an empty array list. So we'll call that a new array list of type string. And then once we've done that, then we can go ahead and put our current string into that key. All right, and with that out of the way, we have successfully grouped every single one of our anagram sets. So we finished steps 1 and 2. The last thing that we need to do is go ahead and return a set of all of our sets. And so what you'll notice is that this is our key, and this is our value. Well, this is one of our values. When we put each of our values into a hash map, the value part of the hash map will contain a list of all of the strings. It will contain this part. And we basically just need to put every single one of those hash map values into an array list of its own. We can do that super simply using a one-liner. We can return a new array list of type list strings, and we'll just go ahead and add every single one of our values from Anna. All right, let's go ahead and run this code, see if it works. Why did it not like this? Oh, I'm just missing a extra close bracket on both sides. Let's go ahead and fix that. Cool, it looked like it accepted this. Let's go ahead and submit our solution. And it works, awesome. So before we go ahead and close out the video, let's take a look at the time and space complexity of this and see if we can clean a little bit of this code up. So let's start with cleaning a bit of this code up. What you'll notice is that we have the exact same line of code duplicated here and here. And so basically the logic here is that we're saying if our hash map contains the proper key, then we just add it. Otherwise, we need to instantiate a new array list and then add our string. So we can really just write this as a single if statement. We can say if our anagram does not already contain the key that we're looking for right now, then we're going to want to go ahead and instantiate that new array list. And then no matter what, we're going to want to go ahead and add our current string to just its key position. And so in that way, we can go ahead and delete this big block of code and replace it with a simple two-liner. Awesome. From there, let's go ahead and determine the time and space complexity. So we're given our array of strings, and let's just say that there are some n strings. Now, converting this to a character array, let's just say on average there are k characters in a string. Well, sorting that array of on average k characters is going to give us something that runs in k log k time, right? And then because we're adding each of these strings to a hash map, we're going to be increasing our space complexity to O of n. So let's take a look at what we have in total here. Let's start with our space complexity because it's super simple. We're just creating a new hash map containing all of our strings from our array. Assuming that this is n strings, we're going to have O of n space complexity. Our time complexity is a little bit more difficult to determine, but not too difficult. We run k log k on each of the n strings, and so we're going to have n times k log k time complexity here. And that's pretty much it. This is the medium problem group anagrams, number 49 on LeetCode, basically the big brother to valid anagram, solved.